Hello, my name is Sultan Mahmoud Sarkabi. I want to talk about what is light, wave, or particle. Light is the smallest quantity of energy that can be transported, a photon, an elementary particle without a real size that cannot be split, only created or destroyed. And what is light, a particle or wave? Both of them is correct. Light is a particle and wave. Discussion first start from particle theory of light. Physicists Newton and Einstein they did experiment in this site, and the experiment shown light is behaving as a particle. And also Isaac Newton wrote a book about light. And the second famous guy who worked on the particle theory was Einstein. He found the definition for photon, and also he said those photon light particles are quantized amount of light. The light has an energy, and it is an energy package, and it has a frequency, a wavelength, and therefore we can calculate it. And the photon and the name photon, I therefore take the liberty of proposing for this uh, hy- hypothetical new atom, which is not light, but plays an essential part in every process of radiation. It is a photoelectric effect experiment by Albert Einstein. And if we question how does this experiment work, let's look this figure. We have a metal surface, and the minuses here are electrons, and the wave package here is incoming light, and the metal is a conductor, and in conductor electrons are free to move, and they observe when the light applied on the surface of a metal. They were able to eject some the electrons. And here the frequency of light it was important. It is it has to be a certain value for this process to occur, and the intensity doesn't matter. The intensity and the energy are a different definition. Light is a wave, or radar acts like a wave. So here the wave side of light, there are more experiments that show light is a wave, which physical phenomena, reflection, refraction, dispersion, diffraction, interference, and polarization. So here the wave theory of light, Huygens, he was one of the first guys who said light behaving as a wave. And here you see an example of two waves intersecting each other if they would travel with the velocity of v over time t. And the other physical phenomena that are showing the wave behavior of light, reflection, dispersion, and other phenomena, diffraction, refraction. So if light is a wave, and here what kind of wave it is? Light is an electromagnetic wave, and if we talk about electromagnetic, we remember Maxwell. This velocity is so nearly that of light that it seems we have a strong reason to conclude that light itself, including radiant heat and other radiations, if any, is an electromagnetic disturbance in the form of waves propagated through the electromagnetic field according to electromagnetic laws. When something creates energy, it also emits radiation depending on, on the amount of energy. The object will emit different types of electromagnetic radiation. When we studied mechanical waves, they were all transferred through a medium, and the medium where the mechanical light travel. Electromechanic waves are special in the fact that they do not need a medium to propagate, but what is creating the disturbance and what is emitting this energy, it's actually electrons. Electrons in materials are vibrated and emit energy in the form of photons, which propagate across the universe. And photons have no mass but are pure energy, and electromagnetic waves are waves that are made up of these photons. And this is the graph of intersection showing the intersection of electric field lines, red ones, and the perpendicular ones are magnetic field, the blue one. And so here nu is the frequency, and lambda is the wavelength, and constant c is here speed of light, and the value of speed of light 3 times to the 10 meter per second, 3 times 10 to the 8 meter per second. And in here, if we want to calculate the energy, first we know the relation between frequency and the wavelength. It is connected to the speed of light, and for the energy it is coming. And electromagnetic waves are in everywhere. Light is only a small part of them. And if we check electromagnetic spectrum, we have the visible region. Actually, it is a very small part of a huge electromagnetic spectrum here. And the wavelength and the gamma ray wavelength is 10 to the minus 12 meter, and radio is 10 to the positive 3 meter. And for radio wave larger wavelength, and for gamma smaller wavelength. So thank you for listening.